everyone, this is Kalpana here. In this video, we are going to solve a differential equation which is non-homogeneous. So let's get started. Problem: solve dy by dx equals to 1 minus 3x minus 3y by 2 times x plus y. Solution: given differential equation dy by dx equals to 1 minus 3x minus 3y by 2 times x plus y. So we can write this as dy by dx equals to minus 3x minus 3y plus 1 by 2x plus 2y. We know that the differential equation of the form dy by dx equals to a1x plus b1y plus c1 by a2x plus b2y plus c2 is called non-homogeneous differential equation. Here a1, b1, c1, a2, b2, c2 are real numbers, and sometimes we'll get c1 not equals to 0 or c2 not equals to 0. Okay, now compare the given equation with this. We'll get, by comparing terms containing in numerator and the denominator, we'll get a1 equals to minus 3 and b1 equals to minus 3, c1 equals to 1, a2 equals to 2, b2 equals to 2. And here we don't have any c2 term, right? So here c2 equals to 0. Okay. In this problem we are having c1 not equals to 0. Okay. Fine. Now we'll check whether a1 b2 minus a2 b1 is equals to 0 or not equals to 0. Okay. Firstly consider a1 b2 minus a2 b1 is equals to a1 minus 3 into b2 2 minus a2 2 into b1 minus 3 is equals to minus 3 into 2 is minus 6, minus into minus plus 2 3s are 6, minus 6 plus 6 is equals to 0, right? So we are having, therefore a1 b2 minus a2 b1 equals to 0, right? So from this we'll get a1 b2 equals to a2 b1, right? Then a1 by a2 equals to b1 by b2, or a2 by a1 equals to b2 by b1. Okay, or you'll get a2 by a1 equals to b2 by b1, right? So now let's check what we'll get for a1 by a2 and b1 by b2. Since we got a1 by a2 equals to b1 by b2, right? So a1 by a2 equals to minus 3 by 2. Then from this we'll get 2 times a1 equals to minus 3 into a2. Likewise, if you consider b1 by b2, we'll get 2 by minus 3, which is equals to, b1 by b2, right? We're having b1 equals to minus 3 and b2 equals to 2. From this we'll get 2b1 equals to minus 3 b2. So here a1 by a2 and equals to b1 by b2 equals to minus 3 by 2. Right? Fine. So here a1 b2 minus a2 b1 equals to 0. Also a1 by a2 equals to b1 by b2 equals to minus 3 by 2, and 2a1 equals to minus 3a2 2b1 equals to minus 3b2, right? See, we are having 2a1 equals to minus 3a2, right? From this we'll get a1 equals to minus 3 by 2 into a2, right? Now substitute a1, a2 values, then you'll get minus 3 equals to minus 3 by 2 into a2 is 2. If 2 gets cancelled, you'll get obviously minus 3. Minus 3 equals to minus 3. Okay, fine. Let it be. Now consider 2b1 equals to minus 3b2. From this we'll get b1 equals to minus 3b2. Again, substitute b1, b2 values. You'll get minus 3 equals to minus 3 by 2 into b2 is 2. If 2 gets cancelled, obviously we'll get minus 3, which is b1. Okay. Now we'll substitute. We got a1 b2 minus a2 b1 equals to 0, right? From this, if this happens, we'll make a substitution. Okay. See here, we have minus 3 in a1 and b1 and 2 in the denominator. Okay. So in this case, we are going to replace the terms containing in the numerator. Okay. Substitute u equals to a2x substitute u equals to a2x plus b2y. Then you'll get u equals to a2 2x plus b2 2y. Now differentiate on both sides with respect to x, then we'll get u equals to 2x plus 2y. Then du by dx equals to 2 into dx by dx plus 2 into dy by dx. Then du by dx equals to 2 plus 2 into dy by dx. Then du by dx minus 2 equals to 2 into dy by dx. To take this 2 to LHS, you'll get 1 by 2 into du by dx minus 2 equals to dy by dx. Okay. If u equals to 2x plus 2y, then we'll get dy by dx equals to 1 by 2 into du by dx minus 2. Okay. Now, consider the reduced equation as equation number 2. Okay. Now, replace a1 that is minus 3 by 2 into 2 and b1 minus 3 by 2 into 2. Then you'll get minus 3 by 2 into 2 into x plus, we are replacing minus 3. Okay. Replacing minus 3 by 2 into 2 into y plus 1 by 2x plus 2y. Okay. We have u equals to 2x plus 2y, right? We are going to replace 2x and 2y by u. So if you consider the first two terms of numerator, you are having minus 3 by 2 on both the time. on both the terms, right? So now we'll take minus 3 by 2 common from these two terms. Then this becomes dy by dx equals to minus 3 by 2 minus 3 by 2 minus 3 by 2 times 2x plus 2y plus 1 by 2x plus 2y. Since we are having u equals to 2x plus 2y, so we'll take only minus 3 by 2 common from these two terms. Okay, don't take minus 3 by 2 into 2 common from these two terms. Okay, fine. Now we can replace dy by dx and 2x plus 2y. Then this becomes 1 by 2 into du by dx minus 2 equals to minus 3 by 2 into, we have 2x plus 2y equals to u. So replace this by u plus 1 by u. Okay. Then 1 by 2. We can take this 1 by 2 to RHS, right? Then you'll get du by dx minus 2 equals to 2 times minus 3 by 2 into u plus 1 by u. Then du by dx minus 2 equals to, multiply these two terms with 2. Then you'll get 2 into minus 3 by 2 into u plus 2 into 1, 2 by u. Here 2 gets cancelled and you'll get minus 3u plus 2 by u. So now take minus 2 to RHS, you'll get minus 3u plus 2 by u plus 2 is equals to minus 3u plus 2 into u, 2u by u is equals to minus 3u plus 2u is minus u plus 2 by u is equals to, you can write this as 2 minus u by u. Now we'll write all the functions of u and differential du on one side and all the functions of x and differential dx on the other side. Simply we are separating the variables. Okay. Then you'll get u by 2 minus u into du equals to dx. So here variables are separable. Since variables are separable, so we can perform integration. Okay. So before performing integration, we notice that u by 2 minus u is an improper fraction. If you represent u by 2 minus u by some p of u by q of u, you're having p of u equals to u and q of u equals to 2 minus u, right? Which is a linear polynomial. Okay, p of u is also a linear polynomial and q of u is also a linear polynomial. So we have p of u, the degree of p of u is 1 and the degree of q of u is also 1. Since the degree of p of u is equals to degree of q of u, from this we can say that this fraction is an improper fraction. So we'll reduce this improper fraction to a proper fraction. Okay, we'll use division method to reduce the fraction. So consider the fraction u by 2 minus u. 2 minus u divides u. 2 minus u into, you need plus u to be cancelled, right? You need to cancel plus 2 plus u, so that we'll multiply some minus 1 to this divisor, so that you'll get minus u into minus 1 is plus u. Okay, so divides into minus 1 is minus 2, minus into minus plus u. This is equals to u minus 2. Divides into minus 1 is u minus 2. Now change the signs and cancel plus u minus u. You'll get plus 2 as your remainder. Right? We know that. Divisor into quotient plus remainder gives dividend. So let's consider this. Divisor into quotient plus remainder equals to 2 into minus 1 minus 2 minus u into minus 1 is plus u plus 2. If here minus 2 and plus 2 gets cancelled, and finally you'll get u, which is your dividend. Right? Since u equals to 2 minus u into minus 1 plus 2, if you replace this u by this, then we'll get you can split the fraction into 2 since you are having 2 terms in the numerator. Then u minus 2 into minus 1 by 2 minus u into minus 1 by 2 minus u plus 2 by 2 minus u. Here 2 minus u gets cancelled. This equals to minus 1 plus 2 by 2 minus u. Here 2 by 2 minus u is a proper fraction. If you represent the fraction by p of u by q of u, the degree of p of u is, since 2 is a constant polynomial, so the degree of p of u will be 0. And degree of q of u, since q of u is a linear polynomial, so the degree of this linear polynomial is 1. Okay, degree of linear polynomial is 1. So we have degree of p of u less than degree of q of u. From this, if degree of p of u is less than degree of q of u, we can say that the fraction is a proper fraction. Okay, so we have reduced an improper fraction to a proper fraction, right? So now we can replace u minus 2, u by 2 minus u equals to minus 1 plus 2 by 2 minus u. Okay, then this becomes, simply replace this fraction by this, you'll get minus 1 plus 2 by 2 minus u into du equals to dx. Okay, then minus 1 plus 2 by. Now take 2 common from these two terms, you'll get 2 times. Since you don't have any 2 as your quotient of u, right? So what you'll do is simply multiply and divide by 2. Okay, it becomes easy to take 2 common from these two terms. Then you'll get 2 times 1 minus u by 2 into du equals to dx. Here 2 gets cancelled. Then minus 1 plus 1 by, you can also write this as minus u by 2 plus 1 into du equals to dx. Then minus 1 plus 1 by, now we'll write the quotient of u separately under brackets, minus 1 by 2 into u plus 1 into du equals to dx. Now we can perform integration. Okay. Since we know that integral 1 by ax plus b into dx equals to 1 by quotient of x, that is a into log mod ax plus b plus integral constant c, and integral dx equals to x plus integral constant c. Okay, in order to apply this formula, we have written the fraction and the quotient like this. Okay, so that it will be easy to solve. Now we'll apply these formulae. Then integral minus 1 into du is minus 1 into u plus integral 1 by au plus b into du is equals to 1 by a, that is 1 by minus 1 by 2 into log mod a u plus b. Okay, equals to integral dx is x plus integral constant c. Then minus u, 1 by minus 1 by 2 is minus 2 log mod minus u by 2 plus 1 equals to x plus c. Okay, then now take minus common, then you'll get minus of u plus 2 log mod minus u by 2 plus 1 equals to x plus c. Then now take this minus 2 RHS, then you'll get u plus 2 log minus mod minus u by 2 plus 1 equals to minus x or minus of x plus c. Okay, now we can replace u by 2x plus 2y. Then this becomes 2x plus 2y plus 2 log mod minus u, that is minus of u 2x plus 2y by 2 plus 1 equals to minus x minus c. Then 2x plus 2y, take this minus x to LHS, it becomes plus x, and also take this c, it becomes plus c plus 2 log mod. Now you can take 2 common from the numerator. Okay, minus into 2 times x plus y by 2 plus 1 equals to 0. Here you 2 gets cancelled. Then 2x plus x is 3x plus 2y plus 2 log mod. You're having minus x minus y plus 1. Minus into x minus into plus minus y plus 1 equals to, you're having constant, right? Plus c equals to 0. Then 3x plus 2y plus 2 log. So you can write this as 1 minus x minus y. 1 minus x minus y plus c equals to 0, which is the required general solution. Which is the required general solution to the given equation. Okay, so this completes the problem. So we have seen a problem from non-homogeneous differential equation in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.